0.1 microfarad to 1 microfarad or less than 10 microfarad. It's something like that, but
Okay.
it's really a function of
Point 1 microfarad to 1
FU
one
microfarad.
one.
Yes,
Okay.
it's the common value.
And electrolytic, not any other, right? You have
Huh?
to use electrolytic capacitor.
Again, it depends on the
Application.
the
For this
application. For
application.
this application, it's not important.
Okay.
Yeah, but for applications that they need really high frequencies, or it contains very high frequency spikes, then electrolytic capacitors are not a good choice. So here then I can connect it to reference as well, and we can use the reference ring to connect the reference of circuit to one of the legs, so it helps to removing the common mode noise of noise that body can absorb.
Do you wanna explain the capacitor circuit, which where the plus and the minus go?
Correct. So this capacitor is between the minus power rail and the ground or reference. The minus is connected to the negative pin, and the positive pin is connected to ground or zero.
Okay.
And this capacitor is between positive rail and the ground, and the ground is connected to the negative pin, and the positive pin is connected to the positive rail.
Okay.
Keep the length of wires that you are using as short as possible. Then it helps you to have a neat circuit, so the debugging and changing the circuit will be easier. Okay, I want you to record this pin. So can you focus on here?
From the top?
Uh-huh.
Yeah. Yeah, see it.
If you can see it, then touch the screen. Touch. Huh? No, I don't think it's focused. But if you see a small space between soldier and the wires or the legs, the pins, then you know that the soldering is not done well. So, one of the stages of soldering is wetting action, which is Okay. Let's show it here. It's the board, it's the leg. Then if you put the soldering bubble and it stays like here, then it's not a good connection. If you could see something like that, then it's a good connection.
Oh, right.
So there we can see a very narrow space between pin, between wire and the solder plug.
And can you also draw the schematic for the capacitor for stabilizing here?
So
Yep.
for a simple circuit, we will have something like that: plus 9 volt, minus 9 volt, and ground or reference or 0 volt. Okay. Then for stabilizing, you can put two capacitors in parallel with the reference and the battery.
Okay. And you want to
Okay.
talk about the plus and the minus?
Okay, so
The
it's
capacitor.
the common symbol of capacitors, but this symbol is not polarized.
Okay.
Polarized capacitor, like electrolytic capacitor, has a symbol like that. So this is the negative
Right.
pin, and this is the positive pin. So here you connect the positive pin to ground and negative pin to minus, negative pin to ground, positive pin to plus.
Okay.
But these voltages are very low, so nothing will happen. But if you are working with hundreds of volts, then it is possible that the electrolyte will be blow up.
Okay.
Another way is using just one 9-volt battery. And use two resistors for having a voltage divider, simple voltage divider, to make a virtual ground for your circuit. So then you can say that, for example, this one is 10K, this one is 10K. So if you consider this node as a 0, it should be plus 4.5, this one minus 4.5. Correct?
Right.
So it's another way of making it, but it needs good capacitors here.
Okay.
Okay.
Here, this one is negative 4.5. This one just because of the resistors here.
Yeah.
Yeah. Okay. Alright.
Okay. Are you recording?
Yeah, I'm recording.
So it's now corrected. It's a good connection. this one, this end has a good, this side has a good connection, but this one is not connected at all. So it's not connected to anywhere else, so I didn't resolder it, but it's a difference between a good connection and a bad connection. Okay. From here to here, for example,
That's okay, man. We'll just use the clips. It's fine. Don't worry. You don't have to make it long.
if you are because you want to connect alligator
Right.
clips to here, I stay a bit longer now. Now it's a ground connection.
Okay.
What else you need?
The
Input, ground, cover.
the ground on the instrumentation. Do you have that?
Oh, correct. So, then we have ground everywhere
Right.
around the board. So the simplest thing is to connect it from here to here.
With the wire.
Always clean the tip of the iron.
Once again, we're gonna mention that the ground of the instrumentation amplifier goes to the outer rim, which does not have any holes, but still can be used as a ground point.
Okay, now you want to check the connections before you connect it to battery.
Right.
So do they have access to
Yeah, that.
multimeter?
Yeah. Mob is now gonna check the connections with the multimeter. He has a different multimeter that compared to the one that we have, but the feature is still the same. And the point is that whenever there is a connection, there's a beep on it, and it's called the continuity test. It's on this multimeter. It's with the ohms, and with our green multimeter, it's the same also. You still have to go to the ohm section, and then you have to press the yellow button to go to the continuity test.
Okay, so this one is a positive. It should not be connected to any of these pins, but this one is the okay, so none of them should be connected to positive, but this one is the positive connection,
Right.
and it's the same as here. Oh, that small beep was the current that charged this capacitor, but after a small beep, then it's disconnected.
Right.
It shows that capacitor is act like a open circuit in DC circuits, correct? And it's again the positive pin of the circuit, which is correct. So this one should be connected to ground. This is the ground. This is the ground.
Right.
What else? What?
The negative.
No, the ground connection. Okay, here. So it's correct. So it's the same thing.
Okay.
But this one is the negative, which should be connected to here and here, not any other pins like that. So it's correct. And if you check it, then for example here we can turn on this little LED with the power of the multimeter. It's good. Okay, so power connection is correct. There is no problem with power connection. Something that I want to check is this one. And this one, okay.
Can you set the RG to let's set it to 3540 ohms. This RG.
35
40 ohms, yeah.
ohms. Oh, okay. You should do that before you connect.
I did.
anything-
We wanna
anything
just make
to
sure.
here.
We
So,
wanna make sure. it's
it
correct.
should not be on continuity.
Right.
Change it to ohm meter,
Okay.
and then put this to here. And now with a small screwdriver.
No, we can use the hands. We can use the hands. Don't worry. I can do it. I'll change it once it comes up.
30,
35 is good.
35.
Okay, that's fine. That's good enough. That's
Okay.
fine.
Okay.
So the RG is set,
And everything
is tested with the
is
multimeter.
tested. There is no problem. Oh, just these two, which is these two should not be connected to each other, and this one is connected to here. This one connected to here. Okay.
Yeah. We now have Mohammed connected with the electrodes, and the LED is flashing. I'll adjust it. Yeah, with adjusting the potentiometer, you can get the LED flashing with the correct threshold.